Before I went into algorithmic trading, I used to be an ordinary .NET developer, and the first job that I ever got as a .NET developer, I was working on a project where people built something called a property proxy, and this is something that is very common, and lots of people are doing it all over the place. Now, the reason why we had a property proxy in back where I was working was that we had every measurement being recorded in a measurement system by being exposed in 2 or 3 measurement systems. So for example, you could expose a property like temperature in Celsius or Fahrenheit or Kelvin, and you wanted to have a way of quickly converting it and exposing it through some sort of property value. Now, the property proxy is actually a very simple construct to build, but it does have a few caveats. So let's actually build one. Now, a property proxy is basically the idea of using an object as a property instead of just a literal value. So here we'll have a class called a property of t. So this is going to be the type that's going to encapsulate a property of type t, and it's going to keep it as an object. So I'm going to say property of t, where t has a default constructor. That's pretty much all that we need. And now we need to actually store the property. So we're going to have private t value that stores the value that we want to keep in actual fact, and we may as well want to have some constructors. So let's have an empty constructor, and let's also have a constructor which actually initializes the values. So I'm going to go into generate code and make a constructor which initializes the value, get rid of all these null checks here. Now in the case of a default invocation here, you may as well remember it can be a reference type, so you may as well initialize it with whatever the default is for the type of t. So here, for example, you can say something like the following. So we can initialize it by calling this, and here I would typically do something like the following: activator create instance of t. So that is a factory method on the activator, and this actually makes an instance of t. Now in addition, you can put a default of t here, but the default of t will give you a null for a reference type. So if you do it like this and you have a null value, that's going to be a null. That's not so great for strings, for example. So for string, you might want to have some value instead of no value, but it doesn't really matter. The point is we have a bunch of constructors, but we also want to expose this property somehow. And the reason for that is that we'll need to actually manipulate this object from the outside in just a moment, and I'll explain why. So we'll have a public t value property with a capital V this time round. So let's suppose that in our model, and the reason why we're building a property proxy is that we want to prevent duplicate assignment. So if the value is already 10 and you try to assign it to 10, we do nothing. That's our domain specific behavior. That's the reason why we're building this proxy. So we may as well leave the getter in the default state, so we can say that the getter just returns a value, but the setter is more interesting because we check whether we already have this value, and if we do, we just return. So we say if equals this dot value and value, then we simply return. Otherwise, we may as well write line some sort of informational line about what's going on. So we're assigning value to, and then let's put the value in here, and we then perform the actual assignment. So this dot value equals value. So this is our publicly exposed property. Now next up, what we need to do is, or what would be nice is some implicit conversions to and from t. So we may as well do that. So we'll have public static implicit operator t, where you convert to, let's say, an int from a property of int, something like that. And here it's very easy. Actually, I should fix the spelling here. Do I get to rename it? Yeah, property. There we go. Okay, so in this case, we return property dot value. So this handles the case where somebody writes int and equals, and they use property of int, for example. And the reverse case is public static implicit operator property of t, which takes a value, and in this case we return new property of t with the value, obviously. And this takes care of the case like if somebody writes property of int p equals 123, for example. That's what the implicit conversion in this case would handle. In addition, I would typically go into generate code and generate the equality members. So I would just pick a value of t, and you may as well just add everything in the kitchen sink here. So let's just press finish, and we get lots of generated code. Now there are caveats here, like for example the fact that we're using, like if you look at hash code, we're using a non-read only value. So as the object value changes, the hash code will change, but that's okay because we actually, in the implementation, what we might want to do is we might want to actually return value, get hash code like this. So this is a more correct implementation, but then of course you have these concerns about, well, what if it's null and all the rest of it? So it can be quite tedious. And once again, value is not read-only, so if it's a primitive type and not a reference type, then you're asking for trouble because the hash code will be changing. But let's not digress here. So we have everything that we need in our property of t, and we can now start using it. So for example, if we were defining a creature in a computer game, you would define it like this. You would say creature, and then you would say public property of int agility get and set, for example. Now you might think that this is correct and that everything is fine. Unfortunately, if you go with this approach, the code that we've written for the setter here will actually not be executed. Let me explain why. Let's suppose that you write something like the following: var c equals new creature, and then you assign the agility. You say c.agility equals 10, for example. Now you're probably thinking, well, okay, if I'm doing this, then what's really happening is somebody says c.set underscore agility with a value of 10. Unfortunately, no, this isn't what's going to happen, because remember, in C#, unlike C++ and many other places, you cannot overload the assignment operator. So what happens with assignment is, as you may have guessed, we're using an implicit conversion from T. And remember, an implicit conversion makes a new object instead of changing the existing one. So you're replacing this with a brand new property. And essentially what you're doing is you're saying something like the following. You're saying c.agility equals new property of int with the value of 10, because that's how we implemented it. So the question is, well, what if we want the mutating behavior instead? How do we do this? And unfortunately, in C#, the only way to actually get this behavior is to rewrite this as a combination of field and property. So you would have your property of int called agility with all the behaviors that you need from a property of int, and then of course you would make this private. And for the public part, instead of having a property of int, you just have an int. You have public int agility, and then for the getter, you return agility.value, and for the setter, obviously you say agility.value equals value. And this is the way that you would go about implementing this. So first of all, let's actually step into the code. I'm going to stick a breakpoint right in here, and let's debug this and just see the fact that it does actually work, and it does land us in the correct place. Of course, what we have to do is we also have to initialize the property, because otherwise it's null by default. So let's make a new property of int, and let's try this again and see how it goes second time around. So as you can see, we're here in the setter. We're comparing the current value, which is 0, with the value being assigned, which is 10. They're not equal, so we do the output and then we return. So that is fine. And now what we can do is we can call this twice. We can actually call the assignment to agility twice with the same value and see if we actually get the same result. So I'm going to say c.agility equals 10 once again, and we're going to execute this and just look at the output. So as you can see, even though we assigned the value twice, we're only actually assigning it once, because our implicit implementation of a property proxy that we've built checks for identical assignments and prevents them by returning from here. So this is hopefully a good illustration of how to build a property proxy, as well as some of the limitations that you get, because typically the this part wouldn't have to be required in a language like C++, because you could simply overload the assignment operator and specify what happens if you assign an integer to a property of int, or if you assign a t to a property of t. But unfortunately in C# you end up doing these kinds of things, which are unpleasant to write, I must admit, but there is really no way around it. So hopefully you appreciate this example of properties being expressed as entire classes instead of just individual values.